Hey all, so today we're going to wrap up the semester with an exploration of some other topics in microeconomics. And today, the final topic we're really going to get into is the theory of consumer choice. Now, it's interesting because we've talked about a lot of microeconomics up to this point. We've talked about production, firms, profit maximization, how are markets structured, what do firms choose to produce, how do they choose to produce it, how do labor markets work. But fundamentally, microeconomics is more than just the marketplace. Fundamentally, microeconomics is about the decisions made by individuals, whether it's individual firms, whether it's individual consumers. And one of the things that helps us understand how individuals make decisions is what we're going to talk about today, and that is the theory of consumer choice. And the theory of consumer choice introduces the concept of why do consumers choose to purchase this good rather than that good? How does an individual think about how they're going to spend their money? What limits are there on the ability of people to consume items? And with that, we're going to hop right into it with the introduction of a few questions and the concept of the budget constraint, or what the consumer can afford. Before we get into the budget constraint, though, I want you to keep these in mind. From the basic theory of consumer choice, we have three interesting questions which arise. First question is, do all demand curves slope downward? The second question is, how do wages affect the labor supply? And our third question, how do interest rates affect household saving? Now let's hop into the budget constraint. The budget constraint can simply be understood as the limit on the consumption bundles that a consumer can afford. You might remember early on in the semester when we discussed the production possibilities frontier. If you remember, we said the production possibilities frontier was basically a curve which showed all the production possibilities a country could have between two goods, given that there was only a limited amount of time in the day or a limited amount of labor hours or any other resource supplied. The budget constraint is basically the same function, but it is the limit on the ability of consumers to spend. So the basic principle here is that if a consumer, for example, only has $1,000, they can only spend $1,000 on goods. Now, we're going to take that $1,000 example and we're going to elaborate it further. We're going to add two goods. In this case, we're going to look at the price of pizza, which is $10, and the price of Pepsi, which is $2. Now, if we come over here and we're going to zoom in here, we can trace out the consumer's budget constraint, this point B, C, A, and all the points in between. And basically, what the budget constraint is telling us is this is every single possible combination of pizza and Pepsi, given that we can spend $1,000 combined on both goods. So for example, if we only wanted to buy pizza, since pizza costs $10, we could purchase 100 pizzas. So our total spending for 100 pizzas would be $1,000 and $1,000 overall spent. That's how we get point A. And then as you can see, we have a bunch of combinations in between here. If we decide to buy only 90 pizzas, then we can buy 50 liters of Pepsi. And that means we have a total spending of $900 on pizza, $100 on Pepsi, and we still have only spent $1,000 overall. And so this is how we derive all the points in our curve. Now, notice that this is a downward sloping curve that gets at the idea that there is something called a relative price between the two goods. Basically, the slope of the budget constraint is telling us how much each pizza is worth in terms of each Pepsi. So basically what you'll notice here is we have a slope of -5. We have a slope of -5. If I can draw this out here, -5 over 1. Well, why is it -5 over 1? Well, simply put, we're saying that you would give up 5 Pepsis for one pizza, or that the equivalent of 5 Pepsis equals one pizza. So the slope of our curve is, this is our, as I said, our relative price, and it's telling us that one pizza is worth equivalently 5 Pepsis. So every time you choose to buy one less pizza, you can buy 5 Pepsis. We see a similar thing up here, right? If you decrease the consumption of pizzas by 10, well, that means you increase the consumption of liters of Pepsi by 50. Now, there's another aspect of this. We don't just have the budget, and the budget determines everything the consumer is going to spend. No, the budget simply determines the limits on a consumer spending. And so what the consumer wants is then modeled in a different way. And to do this, we introduce the concept of the indifference curve. An indifference curve is a curve that shows consumption bundles that give the consumer the same level of satisfaction. What we mean by that is basically every single point on an indifference curve, we presume an individual would be equally satisfied if you offered them that, as opposed to any other bundle. So for example, if we look here, our consumer preferences on the right, indifference curve 1 is this first curve that has points A, B, and C on it. What we're saying here is that if you gave an individual the option of consuming this many Pepsis, let's just say this is 500 Pepsis, and then giving them the option of consuming so many pizzas, say this many pizzas, oh, we'll make this 400 Pepsis. 400 Pepsis, and then giving them the option of consuming, say, 20 pizzas. So we would say they are equally happy with consuming 400 Pepsis and 200 pizzas. They would be consuming, say, 80 pizzas and roughly 200 Pepsis, I think, something like that. That's how the number works out. You could calculate to double check that. But basically, we're saying point A and point C, where C has a higher consumption of Pepsis and a lower consumption of pizza, and point A, which has a much higher consumption of pizza and a much lower consumption of Pepsi, are equivalent, and also equivalent to point B. Now, the interesting thing here is that this indifference curve also has a slope, and the indifference curve slope is also important. The indifference curve slope is the marginal rate of substitution. And the marginal rate of substitution shows us the rate at which a consumer is willing to trade Pepsi for pizza. In effect, it measures the quantity of Pepsi the consumer must be given in exchange for one pizza. So that's why, again, the name marginal rate of substitution. It's telling you what is incrementally how many you have to give up in order to get another, and with equal satisfaction. So notice that at the very top here, the curve is pretty steep. What this is telling us is that at a large abundance of Pepsi, the marginal rate of substitution for pizza is actually quite high. That's showing that we're willing to give up a lot of Pepsis to get just one pizza. That makes sense, right? If you have 450 Pepsis and only a few pizzas, yeah, you'd probably be willing to give up quite a few Pepsis just to get one more pizza. Why? Because you have a ton of Pepsis. At the extreme end, we see that this almost becomes more of a one-to-one transaction where you're willing to give one Pepsi for one pizza. Reason why? You have a ton of pizzas, not a lot of Pepsis. Interesting component here is that based upon this, we'll be able to derive what the optimal consumption point is for a consumer. But before we get to that optimized point, let's talk about a few more properties of indifference curves. Indifference curves are marked by 4 properties. The first one is that a higher indifference curve is preferred to a lower indifference curve. What that means is if a indifference curve which is pivoted further out means you're consuming a higher consumption bundle. And so an implicit assumption here is that more is better, and therefore further out indifference curves yield a higher utility, which we will define that later. A higher utility curve than a shorter, lower indifference curve. Now, the next aspect of this, though, is that indifference curves are downward sloping. What that means is that we are constrained. There is a diminishing return on the amount of an increase in the value of that good. So to give you another example, if you have 400 Pepsis and you add one more Pepsi and have 401 Pepsis, we presume the benefit and improvement in your satisfaction from a 401st Pepsi is much, much less than it would be if you had 0 Pepsis and I gave you 1 Pepsi. Now, another aspect of this, though, is that because indifference curves represent a combination of bundles which are all equivalent, they cannot cross. To explain why, I want you to consider here our figure 3. Notice point A and point C. Clearly, point C is a higher quantity of Pepsi consumed and a higher quantity of pizza consumed. Based upon our first principle, based upon our first property, right, we said a higher indifference curves are preferred to lower ones. So obviously, point C should be preferred to point A. But if you remember, as we also said, the indifference curve is telling us all the different combinations which are viewed equivalently in satisfaction. So every point on line C is considered to be equivalent to the utility at point C, and every point on line A is considered to be equivalent utility to point A. What that means is if the curves crossed at point B, we get basically a paradox. Because if point C is clearly preferred to point A, at point B, that tells us that they're also equal. Because again, the indifference curves are all, every point on the indifference curve is equivalent to another point. So if they intersect, that means these two curves must be equivalent, even though we clearly see that C is preferred to A at this point. So for that reason, it is impossible for indifference curves to cross. They must be spaced out from one another. The final aspect of this is that indifference curves are bowed inward, and that's a result of the marginal rate of substitution. And so as you'll see on the next slide, we can see that the bowed indifference curve is a result of the fact that the marginal rate of substitution decreases as the volume of the good on the x-axis increases. So what this is telling us is, again, the good that you have in the most abundance, you're willing to trade more of it in terms of the other good. So when you have an abundant amount of Pepsi, you're willing to trade 6 Pepsis to get 1 pizza. When you have an abundance of pizzas, in this case 7 pizzas, you're willing to give up 1 pizza for 1 Pepsi. So that is why the marginal rate of substitution bows inward. Now, on an interesting note, there's 2 extreme examples of indifference curves. We have perfect substitutes, which are 2 goods with a straight line indifference curve. Basically, this is a situation in which you don't care between the 2 goods which you are given. What matters is the value of the product of those 2. So for example, nickels and dimes, right? Do you really care if I give you 5 dimes or 10 nickels as long as it's 50 cents? That is the answer. So they're perfect substitutes. Similarly, do you really care if I give you $100 as $100 bill or if I gave it to you as 100 ones? Yeah, it might be a little inconvenient to have 100 ones, but the reality is what matters is that it's equal to $100. So that is an example of perfect substitutes. Now, the other good in the extreme example is perfect complements. These are 2 goods with right angle indifference curves. Now, the reason we say they have a right angle indifference curve is if we zoom down here, notice the example we have is left shoes and right shoes. They're complementary goods in the sense that you need both of them to have a pair of shoes. And notice that the reason we have a right angle is that if you only have 5 left shoes and you have 7 right shoes, you still only have 5 pairs of shoes. And similarly, if you have 7 left shoes and only 5 right shoes, you still again only have 5 pairs of shoes. So perfect complements are a situation in which you must have a set matching ratio between the 2 goods in order to have any increases in utility. To give you an example, this is typically used to explain production questions. So you might have a trucking firm which owns 50 trucks. If they own 50 trucks and employ 25 drivers, they can only run 25 routes, right? So those extra 25 trucks do no benefits to the firm because they don't have the manpower to actually use them to get the full value out of those trucks. So now with this in mind, we can consider how does the consumer optimize and what do they decide to choose? Well, the optimum point is actually quite simple. It's the point where the highest possible indifference curve touches on the budget constraint at a single point. Thus, the consumer chooses a consumption of the 2 goods so that the marginal rate of substitution, that is how much they're willing to give up of Pepsi for pizza in this case, is equivalent to the relative price of Pepsi to pizza. So if you remember, we said that in our example, the relative price of Pepsi to pizza is 5 to 1. 5 Pepsis equal 1 pizza. So the marginal rate of substitution will be the point where the furthest out indifference curve has a slope, the marginal rate of substitution where someone is willing to give up 5 Pepsis for 1 pizza. At this case, we can look over here and we see that this point is the optimal point. Now you might say, why isn't point A the optimal point? Well, this one's quite easy, right? That indifference curve doesn't touch the budget constraint. Basically what we're saying here is you have to consume a higher amount of goods than is possible given our budget constraint. So I2 is the only one which touches the budget constraint and the furthest out. So then you might go, hold up, why is I1 then not the budget constraint? Well, the answer is quite simply, notice that the indifference curve 1 intersects the budget constraint at two different points. What that means is that you have two different consumption points which yield you the exact same utility, and also it's equivalent to utility below the indifference curve, below the budget constraint. So again, we're interested in this point here where you only have a single tangential point between the highest indifference curve and the budget constraint. Now, what is this measuring for us? The way we're considering this and the way these questions are arrived at and answered is it gets us to the question of a concept called utility. And utility is simply an alternative way to describe preferences for the purposes of optimization. Now, what do I mean by that? Simply put, you can't tell me, right, how happy something makes you. You can't tell me how satisfied you are with something. However, what you might do is you might go and take a document and say on a scale of 1 to 10, how satisfied are you with this? If you check a 10, I could infer that you're pretty satisfied with the good. But I could also infer that you are more satisfied with that good at a 10 than you would be at, say, a good that you only mark with a 5 or a 6. So utility is not so much important in that it gives us an accurate measurement of how satisfied people are, as much as it gives us a what we call ordinal way of measuring. And that means that it allows us to organize and order what someone prefers to something else. So, how do changes in income affect consumer choices? Well, let's go back to visit some goods that we've talked about before in our elasticity chapter. You might remember the normal good, and that was a good for which an increase in income simply raised the quantity demanded. So, good coffee is an example of this. If you have a higher income, you want to consume better coffee. In contrast, another example is an inferior good, and that is a good for which an increase in income reduces the quantity demanded. So think about Insta Ramen, Chef Boyardee, Folgers. These are things that at higher income levels, people typically choose to not purchase as much of it. Now you might go, hold on, I like Chef Boyardee, or I like Folgers just fine. That's part of what makes indifference curve so handy, is it doesn't necessarily mean a good, just because a good is inferior for one person, and just because a good is normal for another, doesn't mean it's normal and inferior for everyone. So let's just consider for a moment the situation in which Pepsi and pizza are both normal goods. If our initial budget constraint is this blue line, and it is intersected with the indifference curve 1 at this point, this is our initial optimum. But notice the increase in our income pivots the budget constraint out, shifts the budget constraint further to the right. This makes sense, right? The price of pizza hasn't changed, the price of Pepsi hasn't changed, therefore the marginal rate of substitution or the relative price between the two goods remains the same, and we can consume more of both. So an increase in income shifts the budget constraint outward, raises or there's a higher consumption of Pepsi at the new optimum. So how would we see a inferior good due to an increase in income? Well, let's imagine another example. See that we have increased our income again, and the increase in income again shifts the budget constraint outward. So we shifted from the blue line to the red line. Notice that at this new red line, the indifference curve is tangential at this new optimal point. And at this new optimum point, based upon the further outward indifference curve, we are consuming even more amounts of pizza. So pizza consumption rises due to a change in income, confirming that in this case, pizza is a normal good. But notice that also with this increase in income, Pepsi has declined in consumption. It's dropped from the initial optimum and has decreased to the new optimum. That tells us that for this individual, for these indifference curves, Pepsi is a inferior good. So again, the way you can simply determine whether a good is normal or inferior is when you shift the budget curve rightward, Has the new optimal consumption point decreased or increased the amount consumed? If it's an increase, it's a normal good. If it's a decrease, an inferior good. Now, one more thing to consider here is what happens when you change the price? Well, if you remember, the relative price between the two goods is a ratio between the price of Pepsi and pizza in this case. So what happens if Pepsi's price declines? Well, if we change Pepsi's price from $2 to $1, as we do in this example, the obvious solution here, right, is that that relative price has to change because Pepsi has become relatively cheaper when compared to the price of pizza at $10, while pizza has become relatively more expensive compared to Pepsi with this change. So a fall in the price of Pepsi rotates the budget constraint outward. Now notice that a drop in the price of pizza doesn't change how uh, sorry, a fall in the price of Pepsi does not change the amount of pizza we can consume. Since pizza is still $10 and we only have $1,000, we can still only consume 100 pizzas. However, by Pepsi dropping their price from $2 to $1, we can now consume 1,000 Pepsis versus what we could originally consume of only 500 Pepsis. This shifts and pivots what indifference curve we're going to move to. So as we rotate the budget constraint outward, a new indifference curve intersects at this higher point. And at this higher point, what we see is we raised our Pepsi consumption, right? So we were at this initial optimum, and we have now raised our Pepsi consumption at the new optimum. And this increase in Pepsi consumption has come at the expense of reducing pizza consumption. Now, what we've just seen here and what we've just worked through is what we call the substitution effect. And the substitution effect is simply that when the relative price of one good decreases in relation to the relative price of another good, that ultimately means that the good that is now relatively cheaper, its consumption will increase at the expense of the other good. So again, the income effect is simply the change in consumption that results when a price change moves the consumer to a higher, or when an income change moves the consumer to a higher or lower indifference curve. Apologies for the typo, that should be income. A substitution effect, however, is the change in consumption that results when a price change moves the consumer along a given indifference curve to a point with a new marginal rate of substitution. So the income effect allows us to reach higher indifference curves. The substitution effect alters the position we connect with a indifference curve. So the income effect is the change in consumption that results from the movement to a higher indifference curve, while the substitution effect is the change in consumption that results from being at a point on an indifference curve with a new marginal rate of substitution. Now, a cool little table here I want to have you pause on and really reflect on is table 1. This is a nice handy summary of what we've discussed. It takes into example the goods Pepsi and pizza, and it considers the income effect and the substitution effect. And this gives us our total effect consequences. So let's just assume for a moment that the income effect is that both Pepsi and pizza are normal goods, and so they will consume more Pepsi and more pizza. But the substitution effect is that we've changed the price of Pepsi to where it's relatively cheaper, meaning the consumer buys more Pepsi. While pizza is relatively more expensive, so the consumer buys less pizza. What this allows us to do is analyze the total effects and see that income and substitution effects act in the same direction for Pepsi, so the consumer guarantees buys more Pepsi. However, in the case of pizza, income and substitution effects are acting in opposite directions, so the total effect on pizza consumption is a bit ambiguous. We can see this on the next slide for our income and substitution effects. So if we notice here, I want us to start first with our substitution effect. So we have a decrease in the price of Pepsi. So this is the price of Pepsi. We've pivoted our budget constraint to this point, but notice that as we've pivoted this budget constraint, the same indifference curve we were at is now going to intersect the initial budget constraint at a different point. And at this new point, so we were originally at A. With this pivot due to a change in the relative price, we'll now connect with that indifference curve, same indifference curve, at a higher consumption of Pepsi and a lower consumption of pizza. So point B has a lower consumption of pizza, but it has an increased consumption of Pepsi. So this is our substitution effect. The difference in the consumption of pizza at A to B, that is the effect of our substitution effect. And the difference in Pepsi consumption from point A to point B is the change in Pepsi consumption due to the substitution effect as well. However, at point B then, we're now going to pivot outward and shift rightward due to our change in income. With our pivot rightward, with our change in income, we'll now arrive at point C, which is our new optimum. And the reason it's our new optimum is because, again, we have a further out budget constraint now, and we also have reached a new higher indifference curve. Now, the interesting thing here is that at this new higher indifference curve, at this new optimum, we see again that Pepsi has for sure gone up. This is visualizing what we just talked about in table 1. Pepsi increased because of substitution effect, and Pepsi's consumption has increased because your income has gone up. For pizza, however, the other interesting tidbit here is that we've now clawed back some of the consumption we lost due to the substitution effect. So while pizza consumption went down from point A to point B, it has increased backwards, it has increased again at point C. So ultimately, due to this graph, we can see that overall pizza consumption has declined, but not quite as much as it would have, while Pepsi consumption has increased completely. Now, the theory of consumer preferences actually allows us to do a cool thing here. We can actually derive the demand curve from consumer preferences. In the example we were discussing, right? Pepsi has dropped its price from $1 to $2, or from $2 to $1. From this change, we are now consuming 750 units of Pepsi. So notice that from point A to point B, we see that due to the substitution effect, Pepsi dropping its price has led to a much higher consumption of it. So what does that sound like? A decrease in price increases the quantity demanded of Pepsi? Yeah, that's our law of demand. So we can take these 2 points here, that at $2 Pepsi sold 250 units, and that at $1 due to the substitution effect, Pepsi sells 750 units, and we can trace this over to the demand curve and see that, yeah, $2, 250 Pepsis consumed, $1, 750 Pepsis consumed. So fantastic, right? That's how we derive the demand curve. It doesn't just come out of nowhere, it comes from the theory of consumer preferences. So let's get to our applications. We had 3 questions at the beginning of class, right? And we'll answer the first of those questions. Do all demand curves slope downward? The answer is no. So theoretically, something called a Giffen good exists. And a Giffen good is a good for which an increase in the price raises the quantity demanded. Typically, we think that this is an inferior good for which the income effect dominates the substitution effect. And a historical example of this is considered to be the Irish potato famine. So what we see here is that in this case, an increase in the price of potatoes rotates the budget constraint inward. So what we see here is that the increase in the price of potatoes pivots it downwards. However, we find that ultimately there's a new budget constraint which increases consumption of potatoes or a Giffen good. And so this is what's weird and tricky about the Giffen good concept is, again, we're thinking that there's something, say, an income shift here, which ultimately is powering over our demand for the good. Or in this case, the decline in people's earnings and income is actually what is dominating the increased consumption of potatoes. So how do wages affect the labor supply? Well, this is our next question. This is the work-leisure discussion. And we got into a little bit of this when we were talking about why do employees work and how do labor markets function. Well, the work-leisure decision is simply the idea that an individual has the option to spend hours on increasing their consumption by working or hours enjoying their time and enjoying their actually enjoying what they consume. And so the budget constraint in this case is a combination of the hours you can spend relaxing and the hours you can spend in creating consumption. And so the indifference curves are really telling us, does someone prefer leisure or do they prefer enhancing their income? And this isn't set for everyone, so we're going to consider two different examples. For a person with these preferences, what we see here is that an increase in wage pivots up the amount of consumption they can consume, and for this person, the higher consumption incentivizes them to work more. So we see when the wage rises, in this case, the hours of leisure decreases due to the substitution effect. And due to this substitution effect, we can plot out that the labor supply curve slopes upward. So what we're seeing here is the higher wages are increasing more work from the employee. So this is the basis for the theory of efficiency wages. But again, I mentioned not all indifference curves are the same. And if we look down here at the bottom example, what we see is that for a person with the following preferences, when the wage rises, what we actually see is they're like, yeah, no, this is great. I don't have to work as much to get the same amount of living. So for them, the hours of leisure increases, which shows us that a downward sloping labor supply curve where the hour of labor decreases as income goes up. Now, we mentioned this a little bit, that this is kind of a curved, this is the work-leisure paradox. And the reason why it's called the work-leisure paradox is that basically what we find is that about $80,000 to $88,000, individuals start cutting back on their work supply in order to enjoy their leisure more. And every wage increase over that actually is transitioned into leisure. So up until about $80,000 to $88,000, you can incentivize workers with more by paying them more. But after that point, we actually see that people prefer to enjoy their leisure. Now, there's another aspect of this. How do families choose to save their money? Well, the question here is that if you spend money today, you are increasing your consumption as a young individual. However, if you save money, you're increasing your consumption when you're older. And here, the difference is whether or not the interest rate and the savings earned on saving today and the amount of you can spend when you're older is worth the reduced consumption today. So we see here this trade-off and modeled. So the consumption of a young person has the option of they want to spend about $50,000 today out of a $100,000 salary, and they want to save to where they can spend about $55,000 in the future when they're older. But again, we can see that this leads to two different examples, and particularly depending on the higher interest rate. Higher interest rates can either incentivize someone to say, hey, if I save more today, I can consume even more in the future. And that means the budget constraint rotates outwards and results in lower consumption when young and thus higher savings. However, the other alternative is someone could look at this and go, hey, a higher interest rate, that means I don't have to save as much to be able to consume the same amount I want to in the future. For that individual, what we see happen is this increase in the budget constraint actually leads to a modest pivot rightward to where they actually want to consume more when they're young and thus reduce their savings rate. So again, the key difference here is the only difference here is the shape of the indifference curves. The budget constraints and the budget constraints pivot remain the same, but we see how two different mentalities of indifference curves ultimately derive how much a family is going to save and how much they're going to spend today. So to wrap this up, is this actually how people think? No, but it is a model that captures how people behave. People don't typically go through their day and be like, oh yes, this is how I'm going to optimize my consumption, or this is how I'm not going to optimize my consumption, or I really need to consider if my indifference curve is met. That's not how they do it. However, by using these models, we can start to predict how people are going to behave. And what they help us do is understand how people act as if they are performing as a rational actor. And that allows us to have some predictive possibilities that are helpful and useful in solving other economic problems. But this is a dense theory. I hope you've enjoyed. I hope you've had a good semester, and it's time to wrap up. So thank you all. Take care. Best of luck on final.